Thank you. Can you guys hear me? All right, so my job is to come here today and say that quantum is going to take over and AI is not going to go anywhere. Okay, that's not what I'm here for. That's never going to happen. The idea is, you know, how does all of this coexist, right? Let's get the presentation running. Okay, so uh, we are called Quanfluence. You go to any quantum conference in this country and in many other places of the world, people know us. In an AI conference, not so much. So I'll do a very, very short introduction of what we do so that there's some context setting. And from there, we'll go on to AI quantum, what our thoughts on that are, and so on and so forth, right? So what are we building, right? What we are building is the product on the left. This is a quantum computer. We are actually building a quantum computer hardware right out of Bangalore. Our lab is 15, 20 minutes from here. And this is a long-term game, right? This machine is going to be ready in 2029. But we are sitting here saying that we are going to build a machine which is going to beat the IBMs of the world. And we say that very confidently. That's because we are using a technology which is very, very different from what is existent in the world, right? We are a well-funded company. This is definitely happening. But at the same time, you see there's a product 2, and the product 2 says now, right? And this is a box which is available. And interestingly, a lot of AI people are interested in this box. I will go on to describe why and how the AI guys benefit from this box, what exactly this box does, etc. Crowded slide, not going to spend much time on this, but some of you guys know what quantum computers do. Some of you guys probably don't, right? They do not run spreadsheets faster. They do not do AI inference faster. What they do is they do a very different paradigm of computing. They can do things which all of the compute in the world put together today can't do, right? So you're talking of drug discovery, material design, etc. You're talking cryptography, you're talking climate change simulations. So basically stuff which cannot be simulated now. Imagine that today getting a drug into the market is a 10, 12, 15-year job, all the trials, etc. Imagine doing that in a simulator, right? You can simulate the drug and in, let's say, a month, 2 months, you get a new drug out in the market. So it's a completely new paradigm. And that's what the promise of quantum computing is. We call it the holy grail. Once you get quantum computers out there, I think our lives will improve in a dramatically good way. Our lives will also be difficult because this will break RSA encryption. So all of you software guys out here believe that the internet is safe. The internet is not safe the day you have a large enough quantum computer. Luckily, no one has that right now, right? Our aim is to get it built. But one of the things which these things do is, you might have heard of a class of problem called NP-hard problem. These are optimization problems. And there are a lot of optimization problems in the world which are done by experience today. People know कि ऐसे करने से ये होता है, right? But because exact solutions to these problems are very, very hard to do. Classical computers take a lot of time doing that, right? The Swiggy, Zomato problem of how to send delivery executives around the city in the lowest cost is an NP-hard problem. They break it down. They do a lot of heuristics, etc., to arrive at that problem. So it so turns out that that can be done using a quantum-inspired method. So that is our second product. What this product does is it uses philosophies of physics, takes inspiration from quantum and solves this particular class of problems, just this one class of problems in a quantum-like manner. So solutions which take 20, 25 minutes on an AWS machine run in about 20 seconds, 30 seconds on a machine like this. So this is a game changer when it comes to those industries. So that's the second product. And what we provide for that second product is an API interface. Right? What we learned from the software guys is do everything in an API. So it's an API interface. We have a layer of software which we call the decision layer or the brain. That decides which hardware software combination to call, etc. And it ends up solving problems which cannot be solved or which are very hard to solve 50 to 100 times faster. So that is the Quanfluence product. But the purpose of this talk is to talk about AI and quantum, right? And one thing which we are clear about is that they are complementary technologies. I show that orthogonal thing. And I say, they are completely complementary technologies. They both need to coexist. One cannot live without the other. Maybe AI can live without quantum, but definitely not the other way around, right? And what does optimization do, right? Or what does this quantum inspired or quantum things do, right? They give you what we call prescriptive analytics. You formulate a problem and you solve it, right? You use constraints, you use objectives, and you get a perfect solution. So that's what they do. Whereas what AI does is, it comes up with a lot of innovative ideas, it gives you trends and so on and so forth, right? So the world we see, what you do there is you analyze the trends, right? You analyze the trends, the possible outcomes using AI. So AI will decide, what to achieve, give directions, etc., etc. Probably even formulate the problem. And once you do that, then you use quantum. So you go to quantum, and quantum will tell you the best way to achieve that. So AI will tell you what to achieve. Quantum will tell you the best way to achieve that in a way which is not even solvable today. So this is the marriage of quantum and AI that we see the world going towards. The first application where these two things, technologies have started working together is where AI is helping quantum. Like I said, the quantum computers are not ready. There are quantum computers out there, they're very noisy, they're very small. They don't do very useful things, right? But what we are seeing is we can use AI to do things like noise reduction, error mitigation, etc. So now what is happening is our control loops are learning on their own. And the computers are getting better and better without even having to go and do a lot of manual intervention. So this is the very, very first advantage that we see where AI is helping us do our designs, right? We do noise reduction, error mitigation using that, we do control calibration using that, and there's a lot of hybrid algorithms. The entire quantum software industry today runs what we call hybrid algorithms because the computers are not good enough to run direct algorithms, so now we have AI layers which decide what algorithms to run. Here is an example of how that happens, right? So this is a universe in which AI is at the center of the universe, right? It's sitting there, it's autonomous, and it has tools at its disposal. So, draw a parallel with human intelligence. I mean, if I put a human being in this room and gave him a very, very hard multiplication problem with additions and square roots and all of that, you would be, I don't know what the answer is. But if I gave you a calculator or gave you a computer, you would immediately find the answer. So we look at it as that. So the intelligence, the artificial intelligence is there, it has ideas, it knows what to do. But how do you go and do that, right? So these are the tools at its disposal. So all of these quantum are tools at the disposal of the AI. So the AI can decide on the fly, what should I do, right? Should I just get a software-based quick solver, call it? Should I go to a simulator? Should I go to a real quantum computer? Should I go to some other hardware device? And bring it all back, reason, and give you a reasonable answer. So this is the world of AI where AI quantum works together, and quantum is a tool which is used by AI. Right? The other thing, and this is something which we are very excited about, we've already started doing this, right? Where quantum improves the AI models. So there's a continuous loop running where the quantum machine there, right, is working on your big data set. So the big data and the rule set is sitting there doing calculations all the time and running through scenarios and scenarios and scenarios, and that is the training data which goes into the AI model. So now AI is not calling the machine and saying, do this calculation for me. All of that is being done in the background, or the models are being trained on that. So you already have a trained neural network sitting there which knows the answers to most of these problems. So AI can just ping that model, get the answer. If it pings the model and the answer is that, I don't know, then it can go back and call the machine and take a little more time and get the data. So this will speed it up, make things more intelligent. So there's this continuous loop running. So these are things which have already started happening, right? Some of our machines actually do this. So I'll dive a little deeper into, what actually I mean by when I say this, right? And I'll take something which a lot of people in this room understand, LLMs. I don't understand it as well as you guys do probably. But LLMs and training of LLMs and making LLMs hyper smart or smaller or faster is about a lot of optimization, right? And we've listed on this 3 or 4 places where that optimization comes in, right? Model compression, very, 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 very important, right? So I've highlighted it because I'll dig deeper into that. The smaller the model, you can run it on an edge device, you can run it faster, lower power, I mean, everything depends on that, right? NAS. So again, there are these models and it's all sparse and you're just firing the entire brain when you only need to fire a set of neurons, right? So this is the layer where you figure out what are the optimal layers that need to be fired. Mixture of experts is another one where if you can do it more optimally, the better it is. So all of these are potential places where optimization can be done. And when you think optimization, what do you think? Quantum, right? I just told you that quantum is very good at doing optimizations. It can do optimizations which normal computers can't. And quantum-inspired machines like the ones which exist today are also good at doing this. So this is real. This is something which can be done today. Deep diving into that box, right? How do you do pruning today? People who do core AI know this. What do you do is magnitude based. If the magnitudes are too high, too low, get rid of them, or whatever, right? Or too high, keep them, too low, get rid of them. From that, you get a smaller model, right? You get a smaller model, all of the advantages of the smaller model happen, but what happens? You get loss of accuracy. So people have said that, this is not the right way of doing it, do it in an alternate way. The problem with the alternate way is that you need to run some optimizations, etc. It takes time, but this is a one-time training kind of a job. So it's okay to take that time. And there are various methods which have been proposed. 1994 was that first paper on OBS, which said that you should do some intelligent way of pruning rather than doing direct pruning, right? And it has come down to now what is called ICBS, which is combinatorial optimization, which can be run on quantum machines in a 2024 paper. And we have a version of that called ICBS-Q, where we actually run it on several models. I've taken one of the easier models because just to keep it simple. And the graph here shows density versus accuracy, right? So you don't want to lose accuracy as the density goes lower and lower. So 0.1 means you've compressed the model to 10%. Massive advantage. But look at what happens when you do randomly. There is no accuracy at all. If you throw away, you get a 50%, 70% loss of accuracy. The line at the top is using a quantum computer or a quantum-inspired machine. And you see that even if you go to 0.1, you've only lost 20% accuracy. Might be good enough for a very, very large range of applications. So just an example I'm bringing here to show that, quantum computers today have the power to start doing things to your LLM models which fundamentally change the way these things happen. And this is being talked about everywhere. I was at a conference yesterday where this was the focus of a very, very large company who makes phones. Right? So how do you make the models smaller? How do you make them run on the edge? How do you make them run on low power? Right? So I'm just going to conclude in summary saying that, quantum computing and AI are complementary technologies. They will never take over each other. Maybe AI will take over the design of quantum computers, which is good. All of us won't have jobs. We can go party. And the thing is, quantum and AI aren't complementary technologies. Again, sorry, they are complementary. They are not competing, right? So this is what our ideal vision is. The world of AI plus quantum, right? Thank you. So our machines are available on the cloud. Anybody wants free access, go to quanfluence.com, ask for access. Anybody who wants to know more, info@quanfluence.com. We have a Python SDK, so you can start playing with quantum. It's not very hard to do. It is good fun. And we also have an API if you are using other languages. I don't understand languages other than Python, which is why the SDK is only in Python. Drop us an email, call that number. That number is not mine, unfortunately, or fortunately. So that's it. I think what I can do now is take questions. We have like 5 minutes for questions. So anyone?
Hi, my name is Ayush, and I have questions. So usually, quantum is considered more towards on CPU side, right?
I can't hear you very well.
Am I audible now?
Yeah, much better.
So quantum have been considered more on CPU side, right?
Okay, so a quantum is not a CPU or a GPU. They call it a QPU, a quantum processing
but
unit.
QPU is trying to emulate like CPU as better infinite scale, right?
No, what a QPU does, right, is very different from what a CPU does. A CPU works on ones and zeros.
Yeah.
Right? What a quantum machine does is it works on a one and a zero at the same time.
Yeah.
So we don't compare it to any of these existing technologies at all.
What I'm trying to say is like if GPU allows parallel processing, like could there be a possibility that we could have like a QPU with parallel processing rather than just few bits, like millions of bits?
Yeah. So QPUs eventually will have millions of bits, and they need millions of bits because if you have to factorize two prime numbers,
Yeah.
today all the GPUs, all the CPUs in the world can't do it.
Yeah.
But if you have just 10,000 qubits operational, you'll be able to factorize it, and then you will be able to break your RSA encryption. So these will happen in parallel. The problem with quantum computers, right, is that you cannot measure.
Yeah.
You cannot measure a bit. There is a law, a fundamental law which says that if you measure a bit, you lose the information. So with computers, you can measure, you can store in memory, and you can connect computers together. With QPUs, you can't do that because you can't measure a bit, you can't store a bit. So you have to do all of this in real time without measuring. So that's where the challenges are, and that's why you don't see commercially available computers today which can crack these things.
So you said 2029 would be like the GA, but like Microsoft and Google's have at least some machines. Like
They have some
Manjaro
machines.
and
You should try to use them. They're very interesting machines. They're very noisy.
okay. I think the
They
error rate is like 5, 10, 20%. I don't know. Like
Sorry?
error rate is very high right now.
It's very, very high. So you need 1,000 bits to get one bit which is error free.
Oh.
And the best machines in the world have about 5,000 qubits. So
Yeah.
you can't get more than 4 or 5 error free bits today.
So if you say like we can't get a very high error free solution, what do we use it for? Given, like, for example, you are giving it for free, what do we use it for? What we can play around?
So you remember there was a left side and a right side, right? The left side was a quantum computer. We call it a gate-based computer. That's the holy grail, right? That can solve a very large range of problems. What is on the right is not a quantum computer. It is a quantum-inspired machine. There are no gates in it. So I can't go do drug discovery. I can't go do RSA encryption breaking. I can't do those kind of things. But there are a class of problems which it can do, right? The class of problems which it can do is that it can load an energy function into the machine, and then it can find what is the lowest energy state of that function. And this, it sounds very technical, but if you think of it, it has very interesting uses, right? So this thing has uses across logistics, finance, drug discovery, anything which you want to minimize or maximize, right? Which is across the thing. What I showed you, combinatorial optimization, you want to minimize something. So for all of those, if you have a large number of variables and an interconnection between the variables, that energy function can be minimized. So those are the machines which exist today, and that's what a lot of the quantum software does today. You can convert something into an energy function, load it into the machine, get the minima. The minima is something which then you can use for your purposes.
Can we please bring the mic to the lady in the front, please?
Oh, I have a question.
Yes.
Yeah.
We'll come to you right after this. Thanks.
So, sir, what do you think? Will AGI come first or the Q day? Q day where encryption is broken by the quantum computer. AGI versus Q day.
Q tech.
Q day when the encryption will be broken by quantum.
Okay.
So, what will come first? AGI or that?
What is AGI?
Artificial General Intelligence.
Okay, I don't know what AGI is, but it sounds like the day the world will be taken over by artificial intelligence versus the day the world will break every message which is stored. So
yeah.
I don't know whether you guys know, a large part of the world's storage today is used to intercept. You can intercept any communication on the internet. So they intercept and store. So all the communication which is happening in government circles, etc., is being stored. Because the way RSA works is the day RSA is broken, you can get those old messages and break them. So you can know what Modi said to Trump if you have stored that. And someone has stored it there, right? So I believe this will happen first. People will be able to break RSA first.
Thank you. Thank you.
Okay, in the interest of time, we'll just take one more question. There was a lady here who had raised her hand. For the others, please feel free to connect with him.
I'll be
once
outside
he's-
for some time, so
Yes.
because
So you can
it's
connect
saying
with
time's
Sujoy.
up, I don't want to.
Yes, a quick question here, and then we'll move on to the next session.
Hi, thank you for the session. Will the quantum computers take space of today's data centers? Like, will you be selling to the Amazons and replace AWSs of the world? Just wanting to make sense of the business and business users for you. And how does it look on field? Like, will it be huge centers with quantum computers coming
Yeah.
into place?
So today, if you go on to AWS or GCP or some of these platforms, right, you can actually choose a quantum computer there. You can choose an IBM machine. So I think this infrastructure which has been built is going to stay. You're going to be able to choose a quantum machine, right? And quantum computers cannot, will not, will never replace today's GPUs and CPUs. So you're going to have GPUs, CPUs, quantum computers. So you're going to have data centers around the world consuming lots of energy, destroying the planet, doing this, and and you can go choose whichever one you want. So it's just going to go sit into your AWS stack. Okay, all right.
Thank you, Sujoy. Can we please have a huge round of applause?
Thank you, guys.
Ladies and gentlemen, that was Sujoy Chakravarty, co-founder and CEO Quanfluence. Moving on to our next session,